All right, next topic. Now we need to do computations with distance, time, and the speed of light. Distance, time, and the speed of light. Because space is big. Okay, day one astronomy class. What's the message? Space is big. Really, really big. So when I measure distances around our solar system or to other stars or to across galaxies, I don't want to be using silly things like feet or miles. I mean, they're just way too small for it. I want to use the speed of light as my yardstick. When I measure the distance to the moon, it's whatever, I don't know how many 100,000 miles. The moon is about 1 light second away. It takes about 1 second for light to get here from the moon. The sun is 93 million miles away. But it's easier to remember that it takes light about 8 minutes to get here from the sun. And then I can look at stars, and there are stars that are 10 light years away, and 100 light years away, and 1,000 light years away. That's the amount of time it takes light to get here from there. Light is a wonderful, very useful yardstick to use, and so we need to be able to do computations with it. First of all, the speed of light itself. Given by we use the lowercase letter c to represent the speed of light. It comes from what the Greek word celer, meaning speed or something like that. The speed of light, as you will find if you look in our book in the appendix A there, the speed of light is 3.00 times 10 to the 5th kilometers per second. Kilometers, we're doing a lot of metric in this class. So here are the calculations I want you to be able to do. If I tell you the amount of time it takes light to get here from there, I want you to be able to figure out, in kilometers, how far away it is. And the equation for that is distance equals velocity times time. And this is a general equation. This works all over the place. If I'm traveling at 50 miles an hour for 3 hours, 50 times 3, I'll go 150 miles. So this isn't just a physics sort of thing. But this isn't just an astronomy sort of thing. So here's what I want to do. I want to do an example calculation with this. Suppose I look out and I see an asteroid floating around our solar system, and I know that asteroid is so far away, it takes light 4 minutes to get here from there. How far away, how many kilometers, is the asteroid? So I have a time of 4 minutes. And so according to this equation, I multiply velocity by time, and that tells me distance. My velocity, so distance, equals 3.00 times 10 to the 5th kilometers per second. I multiply that by 4 minutes. And am I ready to grab my calculator and do the computation? Not quite yet. Whenever you do these calculations, look at the units carefully to see if they work out. Here I have kilometers per second. Oh, but I want to multiply that by a distance in minutes, an amount of time in minutes. Well, that's not allowed. I can't do that. I have to first convert those minutes into seconds. Well, this is not so bad. 60 seconds in a minute, 6 times 4, 6, 12, 18, 24. So this would be 240 seconds. You can do it on paper if you need to. That's fine. 240 seconds. So this is the calculation I need to do. If I want to know how many kilometers away is this asteroid that so far away, it takes light 4 minutes to get here from there, I need to take 3 times 10 to the 5th times 240. I grab my magical calculator here. I type numbers in, 3 times 10 to the 5th times 240. And what do I have? This says my answer is 7.2 times 10 to the 1, 2, 3, 4, counting all those zeros, 4, 5, 6, 7, times 10 to the 7. And in this case, what are my units? Well, I have kilometers per second times kilometers, so kilometers cancel out, and I'm left with, seconds cancel out, and I'm left with an answer in kilometers. It will take 7.2 times 10 to the 7th kilometers that's the distance. The asteroid is 7.2 times 10 to the 7th kilometers away, because it takes 4 minutes for light to get here from there. Excellent. Good. Here's the other calculation I want you to be able to do. So that was find distance given time. The other thing is find time given distance. Time equals distance divided by velocity. So I've got an object out there. It's really far away. It takes, I don't know, 10 million, let's see, I've got a distance. It's 10 million kilometers away. If it's 10 million kilometers away, how much time would it take for light to get here from there if it's 10 million kilometers away? Well, let's see. I'm going to need to put in my distance, 10 million, so that's 10 to the 7th kilometers, over the velocity. Velocity, the speed of light. All beams of light always travel at the same speed. Radio waves, all sorts of things travel at this speed of 3.00 times 10 to the 5th kilometers per second. I look at the units. Oh, good. Kilometers above, below, cancel out. I've got divided by per seconds. Per means divided by. So divided by seconds. My answer is going to be in seconds. So I go to my calculator and I go 10 to the 7th divided by 3 divided by 10 to the 5th. And I've got, let's see if I can get my calculator to behave itself. I've got, this is 33.3333 seconds. Now, here's another difference with math. Math, you want to be as precise as you can, show as many digits or something like that. I don't know how it works, but in this class, our numbers are measurements. They're measurements of actual things. And so that means we always want to round off our answer. I don't want to give you all these decimal places because we didn't start our computations with that. The speed of light is only given to 3 figures, to 3 decimal places. So any calculations we do with it will never be good to anything more than 3 figures. 3 figures in this case would be 33.3. So let's round these numbers off. 33.3 seconds. That's the amount of time it would take light to get here from an asteroid that is 10 million kilometers away. Always round off your answers like this. Usually in this class, just rule of thumb, 3 figures pretty much always works. But the more general principle is you look at the number of decimal places given on the numbers we start with, and you should never end up with more decimal places than what you started with because our calculations aren't more precise than that. And that's how we do our calculations with distance, time, and the speed of light. You'll get to practice that a bit on the homework.